Hello everyone, my name is Shravya from Data Science. Today we are going to discuss about intermediate value theorem. The theorem states that it is a continuous function attains all two values between it must also attain all values in between these two values. F of x is a continuous function in a comma b. It's a closed interval. There should lie at least one c belongs to closed interval a comma b should such that f of c is equals to k is a finite. From this picture, we can observe that c is a value is lying between a and b. F of a is a function less than k less than f of b. It states that a point should lie between these 2 points. And coming to this picture, if f is continuous on a comma b, f of on a comma b cap closed interval a and b, and n is a value between this a and b. Here we can observe that f of a is a function, f of b is another function, n is a point, is a value is lying between these two. And here we can see that c is a point is lying between a and b. Let's go with the theorem. Intermediate value theorem. It states that if f of x is a continuous function and closed interval a comma b and f of x is not equals to f of b, then prove that function f of x reaches all the values between f of a and f of b, given that f of x is a continuous function. Here the statement is saying that f of x is a continuous function, f of a is not equal to f of b. Here we have to prove that some values are attaining between these two functions. Here every continuous function is bounded. Let small m and capital M exact bounds of the function f of x. The function f of x attains its supremum value x is equals to 0. F of a is equals to capital M. It is a supremum value, and coming below f of b is equals to small m. It is the infimum value at a and b. Now we have to prove that the function f of x reaches all the values between f of a and f of b. For this, it is enough to show that f of x is equals to k. F of a less than f of b. Let k be any real value between f of a and f of b, that is f of a less than f of b. To prove this theorem, we consider another function. Psi of x is equals to f of x minus k. Here we have to prove that f of x is equals to k. So we are considering another function. Psi of x is equals to f of x minus k. Here put a, b, c in the place of x. Psi of a is equals to f of a minus k, f of b minus k, f of c minus k. By the previous theorem, psi of x is a continuous on a comma b closed interval, and psi of a is not equals to psi of b. Then there exists at least one point c belongs to a comma b such that psi of c is equals to 0. Where a less than c less than b, put x is equals to c. Psi of c is equals to f of c minus k. Here psi of c is equals to 0. F of c minus k is equals to 0. So when you send minus k to the right side, f of c is equals to k, f of c is equals to k, f of x is equals to k. Hence proved f of x reaches all the values between f of a and f of b. And applications of IVT, the intermediate value theorem, is used to test the accuracy in speedometer. It is used to test the accuracy of the speedometer. Generally, the IVT applies to continuous function and it is used to prove the equations both algebraic and transcendental are solvable. The third application, it is used to prove the roots exist or not. It is used to prove whether the roots are exist in an equation or not. Climatologists use IVT to make the prediction about how rising carbon dioxide levels will affect our planet or not. Note that this theorem will be used to prove the existence of the solutions but not actually the solved equations. Let's go with another slide. Intermediate value theorem show using IVT that a function f of x is equals to x square minus 5 by x plus 1 has a root between x is equals to 2 and x is equals to 3. Here f of x is discontinuous only x is equals to minus 1. So on the interval here we have the interval x comma 2 comma 3. The function is continuous. Substitute the values of x and y in the function. So f of 2 we got minus 1 by 3 and f of 3 we got plus 1. Since f is continuous on closed interval 2 comma 3 and f of 2 and f of 3 have opposite signs, there is a value c in the interval, that is a value c in the interval where f of c is equals to 0 by the intermediate value theorem. We know previously we know that f of c is a value is equals to 0, and this is the end of the intermediate value theorem. Thank you.